All right. In section 8.3, we learned how to do long division, and people generally tend to not like to do that, though it's not really all that difficult. They just don't like it. There is another way to divide things out. There is an algorithm called synthetic division. And what you do in synthetic division is you divide by the zero, okay? So for instance, this is 3x cubed minus 5x squared plus x minus 2 divided by x minus 2. So what I'm going to do is I'll take the denominator and I set it equal to 0, and I get, okay, x is 2 is the 0. That's the number I'm going to divide by. So you just set the expression equal to 0 and solve. I'm going to divide by 2. Here's what it looks like. It looks a little weird. You put 2 here, and instead of your normal division bar, it's kind of upside down. And what you do is you go back to the numerator, the thing that you're dividing into, and you write down the coefficients of all the numbers. All right, and first of all, we've got to check to make sure that we have all of our terms. We have a cubed term, a squared term, x to the first, and then our constant. So we aren't missing any terms. If we were missing any terms, we'd have to put a 0 there for the missing term, but we're not, so we're just going to pull off the coefficients. That would be a 3, and then a minus 5. You have to take the sign with the number. And then that's an invisible 1, so it's a positive 1 right there, and then a minus 2. Now when you do synthetic division, it's kind of different than long division. You first have to have something to get you started. So what you do is you drop down this first number 3 here. Anytime you get a number down here below the line, you're going to multiply it by this number out front, by this 2 that I'm underlining here. 2 times 3 is 6. You write the result above the line in the next column. And now what you do is you're going to add. I know in long division you subtract, but in synthetic division you add. You say, what is negative 5 plus 6? Well, that's 1. I just got a new number below the line, so what am I going to do? I'm going to multiply it by this 2. Again, anytime we get a number there, we're going to multiply it by the number out front. 2 times 1 is 2. We always write it in the next column above that little division bar we drew. Now we add again. Anytime we put a number there, we're going to add it with whatever is in that column. 1 plus 2 is 3. All right, so now I got a new number below the line. I'm going to multiply. 2 times 3 is 6. And then negative 2 plus 6 is 4. All right, so if you think about what we did, we just took a cube and we divided an x out of it. So if you had like an x cubed and you divided an x out of it, you would have an x squared, wouldn't you? Well, that's how this works. What you're going to do now is you're going to take these numbers. These numbers are not your answer. You know the answer is supposed to have x's in it. So you take these, and these are the coefficients of your answer. That 3 is going to go with an x that's 1 less than what you started with. I started with a cube, so this will be a square. That means this 1 is going to be it's positive 1, so it's going to be a plus 1x, and that, you know, we would say, we wouldn't normally write that 1 because it's invisible, so I won't. And then if you keep going down, the next thing you would come to would be your constant term 3. Now you have a remainder of 4. Well, what do you do with that? Well, you say, okay, well, that's 4 over, you're not going to write 4 over 2. You got to remember that what was that 2 really? Well, it was really this x minus 2 that was down here, wasn't it? And I just divided by the 0 in this algorithm. So what I'm going to do is take this. This right here is always the remainder. If the remainder is 0, it means it divided in evenly. Here we don't have 0. We have a remainder of 4. So what I do is I put that 4 over x minus 2. That's how I get all the x's back into it. So people like this because it tends to be just really quick adding and multiplying, and then you just got to go put your values back in for your variables. Thought we'd look at number 9 because it has a lot of things missing, doesn't it? What is it missing? Well, it's got a x to the 5th, but we need an x to the 4th term because we got to have each term represented one exponent down. So there's not any x to the 4th, so I'll put 0x to the 4th. And there's not any cubes, but I got to have a cube, so I'm going to put 0x cubed. And there's not any squares, but I need a square, so I'm going to put 0x squared. And there's not any plain old x's, which are x to the 1st power, so I'll put 0x. I could put an x to the 1 on it, but I just won't. And then there's the minus 1. And what we're going to do is we're going to divide that by x minus 1. Now, if you remember what we do from the last problem, we take this x minus 1 and we set it equal to 0. We're finding the 0 of it. So if you add 1 to both sides, we know that that was going to be x equal 1. This is what we're going to divide by, not minus 1, but a positive 1. Okay, so it's always, when you're doing this, it's the opposite of the number on the bottom if it's something like this. There's some other kind of problems we'll need to look at that work a little differently, but for the synthetic division to actually divide, this is what you do. So we're going to put our 1 here that we're going to divide by. We're going to draw our upside down division sign, and then we're going to put in all the coefficients. Now this x to the 5th has an invisible 1, so I'll write a 1 there, and then I got to put the 0 with the x to the 4th, the 0 with the x cubed, the 0 with the x squared, the 0 with the Plano x term, and then the minus 1. So here we go. Let's go through the process again. You always drop the first number down and write it, and once you write anything there, you multiply it by this number that we're dividing by, which is the 1. 1 times 1 is 1. Anytime I get a number there, I'm going to add it, so 0 plus 1 is 1. Since I've got a new number here, I'm going to multiply it by this 1 out front. 1 times 1 is 1. I'm going to write it here. 0 plus 1 is 1, so I'm writing it. Got a new number there, multiply it by the number out front. 1 times 1 is 1. We always write the result in the next column over, but above the line, and then we add those two numbers once we write it there. 0 plus 1 is 1. Got a new number down here, multiply it by the 1 out front. 1 times 1 is another 1. Add those two together, you get 1. And then you got a new number here, so you multiply it by the 1 that's out front. 1 times 1 is 1. And now we add negative 1 and 1 together, and we get 0. This is good. The reason this is good is when I get a 0 there, that tells me that's the remainder of 0. That means I'm not even going to have a remainder here. It means that x minus 1 went in evenly into x to the 5th minus 1. Well, what was the result? Okay, if I'm going to write my result, what all this tells me, I notice that I started off with the x to the 5th, so I always bump the exponent down 1 because you really took an x to the 5th and you divided an x plus some other stuff out of it. So that bumps the exponent down to x to the 4th, so it's always 1 less than what you started with. This is 1 x to the 4th plus, okay, the next exponent down would be an x cubed, and its coefficient would be this 1. The next exponent down would be x squared, and its coefficient would be this 1. Okay, if you go down from an x squared, you just get an x to the 1st, which we just write as x, and that's its coefficient, 1. And then the constant term always comes last. My constant term here is the one I just circled. And since it went in evenly, I don't have any remainder. I don't have any fractional part left. So if I clean this up, we don't write the invisible 1. I would just write that the answer is x to the 4th plus x cubed plus x squared plus x plus 1. Now, how am I going to use this? Well, this is a fast way to divide some things out. So if you've got a function that's a fraction, which is called a rational function, it gives you a way to actually rewrite it. And in calculus, we would do this. This is how we would have looked at this function in calculus. The other thing this also helps you do is to break an equation down. We know how to factor certain things, but sometimes we can't factor. And maybe something would reduce. Well, I can use synthetic division to keep breaking something down over and over again until I get it into its smallest factors. So what we did is, if you think about it, my answer down here, if I multiplied it by the x minus 1 on the bottom, I would get back x to the 5th minus 1 up here where we started. So what you've done is kind of found a way to divide out factors when maybe it's not obvious what you should do. Another one on here, 15, and if it times out, at least it'll get you started. So you may not get the whole thing on there just because sometimes I run out of time on the video. But we'll get as much as we can, and that way maybe it can help you get started. 6t to the 4th plus 5t cubed minus t to the 10t plus 4 over 3t minus 2. Okay, one thing I noticed, there's a couple of things about this that make it a little different. Well, one thing that I need to make sure I know is that I'm missing my square term, aren't I? So let me add in a 0t squared. And you may not be able to read that because I'm trying to squeeze it in and there's not enough room. So I'm going to add in a 0t squared. So if I'm going to write down my stuff for synthetic division, my coefficients inside the little bracket here are going to be 6, 5, 0 for the t squared term, then a negative t, and then a 4. But there's another problem here. We always divide by the 0, and sometimes it's okay, and then sometimes not so fun, okay? So we have 3t minus 2. Well, we can only be dividing by, we need an expression that says just with a t minus something. So what we do is this, we factor out the t, the 3 from the t. So if I factor out a 3, that would be 2 divided by 3 over here. So what am I going to divide by? You're probably not going to like this. What I'm going to divide by is I'm going to take this t minus 2/3, and I'm going to set it equal to 0 and solve it, and I get, if I add 2/3 to each side, I get t is 2/3. That is what I'm going to divide by out front, which means, yes, we're going to have fractions here, okay? And I'm not excited about it either. So here we go. But we do want to know how to do these. A lot of books never get into this, so I'm kind of glad this one does. You drop your 6 down. Now 2/3 times 6. I may have to come over here to the side to do a little math, so that's what I'm doing. 3 goes into 3 1. 3 goes into 6 twice. 2 times 2 is 4. So I'm going to write my 4 here. Now 5 plus 4 is 9. Okay, so what's 2/3 of 9? Let me come down here and do a little work. 2/3 times 9. Well, 3 goes into 3 once, and 3 goes into 9 3 times, and 2 times 3 is 6. So far, it's not as bad as maybe we thought it was going to be. They've kind of crafted a problem here where it's not so bad. So I add the 0 and the 6, and I get a 6. And now I got to say, okay, well, what's 2/3 of 6? Well, I did that a while ago. Remember, 2/3 of 6 up here was 4. You can do it again if you've forgotten it, but, you know, I don't want to redo work if I don't have to. Now we add, what's negative 10 plus 4? It's negative 6. Well, what's 2/3 times negative 6? Well, it's going to be a negative. And 2/3 times 6, we already said that was 4. And then 4 plus minus 4 is 0. So what is my answer? Well, I started with up here with a t to the 4th. Okay, so I'm going to bump the exponent down 1. That means that this 6 is going to go with a t cubed. 1 exponent down from what I started with. Now I just keep going. That's a positive 9, so I'll put a plus 9, and I'll put a t with 1 less exponent than I had before. And then I've got a 6 next, so that 6 is going to go with a t to the first power, which is just a t. And then the minus 6 is the constant term. Notice that I have a remainder of 0, so I will not have a fractional part left over. So this is my answer right here. So even though it looks like it was going to be horrible, it wasn't as bad as maybe it could have been.